This is Brian Putt. Today I'd like to talk to you about phasing capital costs over time in an Excel model. Probably you have done a cost and schedule risk analysis and have a distribution for the schedule and for the cost. But then the question becomes, how do you put it into the Excel model? If you want to do a complete model, you need to do this. Quite often I'll admit that adjusting the schedule is difficult. But it's important to include the cost uncertainty that comes out of your CSRA. So we'll show the complete analysis and you can do whatever is appropriate for you. And the objective here is to come up with the project cost spread out over time, as shown here on this graphic. So if we think about expenditures versus time during a construction period, oftentimes there's a low level of expenditure early on. This is percent of time. So because we're doing some final engineering and whatever, we haven't purchased any equipment. And then we order a bunch of equipment, we have to make payments, and after it all gets on site, then we need to install it. And so then the spend rate kind of slows down again. So it looks somewhat like this. And it depends upon your particular industry and the type of project you're doing. But typically we found in the oil industry that the distribution was about the same if you look at percent of time of time versus percent of cost. So once you've got one of these things based on some historical data, you can probably use it for all your projects. Then we're going to fit it to a generalized Metalog distribution using the cum time percent on the y-axis and the cum percent spend on the x-axis. So here's the process flow chart. If you think you understand all this, you can kind of skip through this part, but basically we're going to use historical data. The more data you have, the better, and you're going to get a paired set of percent the project completed versus the time on the project. That's a paired set. We'll put this to the Metalogs. And then in the Metalog distribution, we need to make sure that we convert the uncertainty variable to a uniform so we have uncertainties. And then we'll define cell B6 as an output variable. And then we can generate a distribution and copy that Metalog SIP on the PM table as some values. Alternatively, we're going to actually show you a different way of doing this now, which is going to actually use the values on the SIPmath chart data. Once you have that done, you can come in here and use either the percentile command, or we can use a lookup command to come up with the percent of time to obtain the cost. And that percent of time comes from taking our CSRA results. This is the results for this particular project, that defines the total schedule time and defines the total cost. And so that schedule time is going to come into here. We find the percent of time, because we've got a period model, whether that's monthly or annual or quarterly, whatever it might be, and we can calculate this percent of time. And once we have the percentage of cost, we can calculate the total cost in that period, and then we'll repeat that process for each period. So what we're looking for in the Metalog, it looks like this. We typically would think of it as percent of time versus percent of cost. And so this is what you might think about, probably easier to explain what I showed previously. But what we want for the Metalog is actually the reverse of that. We want the percent of cost on the x-axis and the percent of time on the y, because what we're going to do is we're going to change that random number, and let's say we're 40% into the project and time scale. So we'll come up here to 40%, and that would say at 40% of the project I've spent, call it 55% of my money. So this is the way it'll look like when you actually get the distribution from the Metalog distribution. And then the resulting time series will probably look something like this, which I've already shown you. The other thing you might want to check in your model is the correlation between the cost and schedule risk. And so take the data from your CSRA model And if you have both, you can plot the correlation of those two, plot this chart. So you can see this was an example that we had, and it shows that there is some correlation here of 0.51 between the time to complete and the cost. And here's that paired set of data. This has 1,000 different outcomes. I've just shown you a few here. In the next video, we'll go into the model and look specifically on how this is all done. If you want more information on SIPmath, you can visit www.probabilitymanagement.org. Read The Flaw of Averages by Sam Savage. He has a new version coming out, I believe, pretty soon. And you can review my many videos on YouTube channel, of which this is one. But it covers the cost of schedule risk analysis. There's several various videos on that, portfolio, value of information, and then if you just want to kind of have some fun, look at the birthday problem. Let's make a deal. There's a frog problem and a taxi cab problem. Hope you've enjoyed the video. Thank you.